So we are coding reset handler, but before we write code, let's take a look what the reset handler is supposed to do. So the reset handler is supposed to get the system ready for the C code. So what this will do is it will initialize the data section. It will move the contents from flash to RAM. In our linker script, we had specified the data is to be stored at RAM, but for now this is at flash. So during the boot up time, the data from flash has to be moved to RAM. And the second thing that the reset handler is supposed to do is to move or initialize the BSS sections by moving zeros to it. So this is the placeholder for all the variables that are uninitialized data. So this part of code will move zeros to the whole thing here, and the data will, all the contents of data will get moved from flash to SRAM. So let's start coding this. So reset handler, let's see, move into R1 0. We populate R1 with 0, and then we say we branch to loop underscore copy underscore data. So these instructions, the assembly instructions, the handy reference for this would be the STM32 programming manual. In this, we will see the STM32M4 instruction set. And here we can see all these instructions, their brief description, and they're all variations. We have to be careful with the variations because there is a slight difference between them and how they operate. So going back to our code, we are going to create a kind of a loop to copy the data from flash to SRAM. This is kind of a for loop where we will it would look something like this. Let's see. For I equal to 0, I less than the end data address, and the I plus plus. So okay. Data begin address plus I. We can say this as data in RAM equal to data in flash. This is the algorithm that we are going to implement. We will just implement it in assembly. So we are going to move to the loop, and the R1 is kind of equivalent to the I here. So loop copy data, and here we'll populate register R0 with the starting address of data. So the starting address of data was specified here in our linker script. So this is the starting address of data. This is end address of our data. LDR R3. So we moved the starting address of data to R0 and end address of data to R3. So the end address is here R3. Then we add R0, the starting address, with R1. So we add the starting address with R1, and we compare it, and then this is populated into register R2, and finally we compare R2 with R3. If it's less, we will jump over to copy data. And we have to write this function. So this will do this actual move. Or if it's done with this loop, we will move to the next step, that is loop clear BSS. We'll clear the BSS next. Okay. So writing the function copy data, the data section. We load R3 with this is the address from Flash that we get here, SI data. It was defined in the linker script. We go over here, and finally we load in R3. Now we're moving the contents of Flash. R1. We add R1 to the beginning address, then we store it. So load moves the data from the Flash to R3, and store then moves from register R3 to RAM. So this is basically moving the data from the Flash to RAM. And finally, we will increment. So we just implemented this, so where we moved all the data in Flash to RAM. Okay, next we will initialize the BSS segment.